Welcome to this lecture on the end-of-life management of EV batteries, focusing on lithium-ion batteries. My name is Émilie Martin. I work as a researcher at the Urban Living Lab Center, which is a UN Habitat collaborating center hosted by the Wuppertal Institute, the Technical University of Berlin, and the MIT. The information I will share in this lecture stems from learnings gathered in the Global E-Mobility Project Solutions Plus and sister projects such as SESA, which stands for Smart Energy Solutions for Africa. In this project, we provided training sessions and developed knowledge products on the end-of-life management of EV batteries. Why is it so important, first of all, to address this topic? Electric mobility is now getting to a market size where it really matters to think about what will happen at the end of automotive life. Lithium-ion batteries are going to dominate the EV market for the coming years, and a sizable amount of them will be retired by 2030. So far, knowledge has been mostly produced on other types of batteries, such as lead-acid batteries, or the type of electrical and electronic waste. It is therefore vital to think about the end of life and to design it in a circular way. What do we mean with the circular approach to EV batteries? Circularity starts in the battery sector, where batteries should be designed in such a way that they can be dismantled for repair or reuse purposes later. That's the first step that you see. Then the battery goes into its automotive use. There, it is possible to try to extend its lifespan by repairing defective cells, as you see in step number 2. After a certain number of charge and discharge cycles, the battery will reach its end of life in the electric vehicle. What is really critical to know is that the battery still retains 70 to 80% of its initial capacity at that moment. It can't be used anymore in a vehicle, but can be used as energy storage system. That's what you see in step number 3. Recycling, in step number 4, should only come at the final stage, after the battery has been used in its second life in the energy sector. Here in this presentation, I'm going to focus on repurposing, or the second life of EV batteries. Repurposing or reusing EV batteries as energy storage systems can serve a variety of purposes. First, it can help with the management of the electrical grid by storing energy at periods of low demand, for instance at night, and releasing it during peak demand. In addition, energy storage systems are needed to store electricity produced by renewable energies that are intermittent by nature, for instance wind or solar. Energy storage systems can lastly be used as power backup, especially if the grid is unstable and replace, for instance, polluting diesel generators. Repurposing is not a theory, but it is something that has been already proven in real-life cases. Here you see a very large stadium in Amsterdam that uses a combination of solar panels and retired batteries from electric vehicles. The World Economic Forum estimates that in a target scenario, 61% of batteries can be repurposed in 2030. Repurposing offers a number of environmental gains, as it enables to delay the recycling phase, and it enables avoid using new resources for energy storage systems. It could reduce the costs of e-mobility, as selling the battery for repurposing can offer extra revenues to manufacturers. It can also help create new business models and employment opportunities. It is, however, still a new practice, and a couple of challenges exist, such as, for instance, the lack of data on the remaining capacity in the battery, concerns regarding safety and liability, or uncertainties regarding the economic feasibility of it. However, these challenges can be addressed, and you will find more information in our fact sheet on repurposing. Now, let's zoom into a specific case: batteries used for electric two-wheelers in East Africa. There, repurposing benefits from really enabling conditions and opportunities. First of all, the dominant model for electric motorcycles so far in the region is battery swapping, or battery as a service, where empty batteries are exchanged against fully charged ones. That's what you can see in the picture. Batteries are not owned by the driver, but they remain in the ownership of the e-mobility provider. For these reasons, providers are incentivized to make the battery last as long as possible. The provider also has control over the entire pool of batteries and therefore can more easily design their end of life. In addition to that, energy storage systems are critically needed to address power supply interruption, which Africans in several sub-Saharan African countries. For these reasons, a couple of innovative companies addressing the end-of-life management of EV batteries have emerged over the last couple of years. Here, I'm only showing you a few examples in East Africa and South Africa. For instance, SLS Energy, based in Rwanda, and Reserve, based both in Rwanda and in Kenya, providing the entire supply chain from collecting up to recycling, and that has partnered already with Ampersand for the repurposing of their batteries, but also Uyilo, based in South Africa, or Waga, based in Tanzania. And there are a couple of other organizations that tackle other types of e-waste and whose experience and knowledge can also be leveraged. In the context of Solutions Plus, we have gathered feedback and knowledge from electric mobility companies, energy storage companies, and repurposing companies based in Africa. We identified opportunities to develop local value chains and reap economic gains from retired EV batteries. We also identified technical challenges, mostly to collect EV batteries and obtain reliable data on their remaining capacity. There is still financial uncertainty as customers are not aware of the second life of EV batteries, or they may be reluctant to use them. In a report that we will publish by the end of the year, we will dive deeper into possible answers to these challenges. Thank you very much for your attention. Please don't hesitate to reach out to me via email if you have any further questions.
Hi everyone, welcome to the electric vehicles end-of-life battery session in the CESA project context. Welcome to this session called Recycling Lithium-ion Electric Vehicle Batteries. My name is Juan Carriquidi. I'm a researcher at the Urban Living Lab Center at UN Habitat Collaborating Center, capacity building for the transformation of urban mobility, energy, and resources sector. A bit more about the context. Most of the information gathered in this presentation comes from the Solutions Plus project and its partners. So I will start with what you will learn in this video. First, what is the end of life management of EV batteries? Second, how to move towards circularity in EV batteries, and finally, the core of this presentation is the basic of recycling EV batteries. Towards circularity, first, regarding EV batteries, is the design of the battery to anticipate circular management. Second, extend the lifespan by repairing and refurbishing the batteries. Third, extend the lifespan by repurposing to energy storage systems. And finally, recycle the battery pack to recover the materials. Electric vehicle batteries. On the left hand of your screen, you can see the battery pack with several components such as housing, cabling, electronics, metallic parts, and so on. A couple of things to take into account before recycling EV battery pack. First, recycling an EV battery pack at the end of its life is an important step in ensuring the sustainability of electric transportation. And you have to remember that recycling these batteries is crucial for minimizing environmental impact and conserving valuable resources. Um, Finally, if you are not sure about any step in this process, don't hesitate to seek advice from local authorities, EV manufacturers, or a certified recycling facility. Well, regarding the recycling electric vehicle battery pack, the step-by-step process could be first contact the manufacturer or dealer from which you purchase the battery pack or the electric vehicle. They may have specific programs or recommendations for recycling the battery. Check local regulations, research local regulations regarding the disposal and recycling of EV batteries. Different regions may have generally have specific guidelines, regulations, and resources for handling these type of materials. Locate a proper recycling facility specialized in handling lithium-ion batteries or other types of batteries. These facilities have the expertise and equipment to properly recycle and dispose these battery packs. Um, Transportation and handling um, is one of the key. The transportation and handling might require special handling procedures due to the potentially hazardous materials in the battery pack. Then the battery dismantling. The recycling facility will dismantle the battery pack. This involves removing individual cells and components, as you can see in the picture. And finally, the cells will be processed separately. Cell sorting and testing, if it's the case. Then recycling the components, different components of the battery pack will be recycled separately. For instance, metals like cobalt, nickel, lithium can be separated and reused. A proper disposal of hazardous materials, such as sub-products from the recycling process, have to be disposed in an environmentally responsible manner. Compliance with environmental standards for every country, every region. And finally, the documentation and records is very important for this type of materials. Keep records of the recycling process, including certificates and so on. The documentation may be required for regulatory compliance. Well, then regarding the electric vehicle battery structure, you can see there the battery pack. Every battery pack is composed by modules which are composed by cells. Then, regarding the cell components, you can find um, mm, mostly something called black powder. The 65% of the cells uh, can be separated as black powder, then electrolyte, plastic foils, aluminum foil, and copper foil, in the percentages shown in the graphic. What is the black powder? It is a mixture of cathode, anode, and electrolyte materials. And the recycling rates are more than 85% for nickel and cobalt, and close to 70% for lithium. Well, finally, regarding the recycling process, there you can see um, a facility line where you can start sorting the batteries, recovering modules or cells, uh, discharging the battery pack and disassembled the battery pack, uh, um, obtaining energy, metals, plastics, BMS, cooling units, wires, bus bars, and so on. Then you can go to the crusher into an inert atmosphere, a thermal drying at high temperature and decreased pressure. Then the materials go through a magnetic separator, where you can obtain the magnetic materials, and before that the electrolyte recovery. Steel and nickel separation are obtained there. Then seismosensation release coating materials. The hammer mill and the zigzag sifter, where you can obtain a light and a heavy fraction, such as the first plastic foils and coating, and second aluminum and copper foil. Um, then, at the end of the process, you can obtain the black mass in a shape of powder and the plastic foil, by sieving the materials. And finally, you can obtain copper and aluminum by conductive or density separator. So that's all regarding the recycling electric vehicles battery packs. Thank you very much. Hope you enjoyed the presentation.